That's a good suggestion. I'll go check that out.
Yeah, they have all kinds of good stuff on that. I've read it before.
All right.
I tried making something like that.
Hello, and welcome to another episode of Handmade. Hello.
That was horrible. That was literally the worst thing I've ever heard.
Yeah, my audio's
Not
going
even
again.
joking.
I couldn't make that out at all.
Hello, everyone, and welcome to an episode of Handmade After Dark. I'm joined by two lovely gentlemen and an asshole. I'm joined by wonderful four-coder master, Alan Webster. Our annotation prince, Miblo.
Hi, folks.
And an asshole, Zach.
Hey.
Okay, so Alan, you want to talk about like coding tutorials,
Programming tutorials and programming like educational materials. Like in particular, there's a whole bunch of different angles on this, but there's a whole bunch of different kinds of programming tutorials, and it's something that everyone in the community has been talking about more and more frequently recently, because the network is planning to start hosting educational material sometime in the future. So what I'm curious about is what everyone thinks makes a good programming tutorial, and also there's different like levels of programming tutorials that exist. There's like, you've never programmed before, let's start programming. And then there's like, you know how to program, but you want to learn C. You've never, like, you're good at programming, but you want to learn advanced stuff or how a computer works and all that kind of stuff. So I'm just curious if there are any interesting thoughts out there about what kind of tutorials you want to see on Handmade Network, and what makes a good tutorial versus a bad tutorial, what medium they should be in. Should they be videos, articles?
I think the first thing we should cover is what do you guys already have that you think is a good tutorial, for example? Like because I'm sure that it ranges for everyone. So what is a good one that you have used or seen? Like,
well, that's what I'm asking you guys. But I mean,
like,
personally, good tutorials that I've used. The best sort of tutorial I've ever used was a written tutorial, but not for C. It was for Lua. Like the sort of introduction to Lua worked pretty well as a tool for learning the language if you were already a programmer, right? Which is how I used it. So that one worked pretty well for me. And that was basically just a series of pages like, here's how you're familiar with these constructs, here's how they work in Lua. But I feel like that's the easiest sort of tutorial to make, which is you're already a programmer, let's just give you the constructs of this language, how you make a variable, how you make a function, and so on.
I haven't used too many tutorials at all. A tutorial I would like to see is a modern OpenGL tutorial that doesn't use glue or glut or all those things. Like, actually shows you how to do the entire thing on Windows, because that's the only place.
I could totally do that.
Yeah, that would be neat if you.
No, but it shows everything from crazy shader shit to like how to do multiple videos and shell lists, all that stupid stuff.
Mm-hmm. Yeah. That would be neat. I mean, there's probably stuff out there like that, but doing a good one's always hard.
So
there's not.
The things I've learned is when you're looking at programming tutorials, it's really hard to find stuff on Direct3D. Really hard to find things on Direct3D. Really hard to find things on OpenGL. Or good like actual readable OpenGL examples that still work.
And that does not use glue. They all use glue or glut. Every single one.
Well, you should know how to replace glue in your head. It's not that hard. Or I could literally show you in 30 seconds. But and then what was the other one? Oh, C. There is no good C tutorial anywhere. It doesn't exist. There's that learning C the hard way one, and that uses like a million libraries for like testing your code and like doing lexing and stuff like that. And I'm just like, I don't care about that either.
The learning C the hard way is good up to a point. It's good when it's just showing you the language constructs, but when it starts hitting stuff where, okay, now we pull in 4 different libraries to do this.
Our Zach is gone.
Our Zach is gone.
It's connecting again.
Our Zach is back.
I have a button on my mouse. I clicked and it went back. I was going to learning C the hard way because I wanted to see where it went bad.
But there's a place where it's at least decent, where it just shows you the language construct, which is all right, and then it just turns to dog shit.
Wait, learn C the hard way isn't free anymore.
Wait, what?
What?
No, it costs $3.
Are you sure here? You see,
learning C the hard way. I'm googling it. We're all googling it.
Yeah.
No, it's not free.
it's not free. It's even worse.
Yeah, no, it's not free anymore.
But you can still like, aren't the Python one still? No, the Python one isn't free either anymore.
Yeah, he put this all behind a paywall. I love this
Awesome.
guy. Who's the guy who wrote this?
No. If you look on, okay, for Python at least, under the buy button you can learn Python the hard way for free right here. Video lectures not included, which is fine, but there isn't that for C.
Yeah, no, there isn't that for C.
So you guys didn't even think learning C the hard way was that good. So who cares?
No, it wasn't that good. I think it was the best though. I would say it was the best.
It was still decent.
Now, learning C the hard way was that to learn C if you were already a programmer, or
I think it was straight from scratch. If I remember correctly.
It was very like, this is an if statement, which
Which
is not how do you write an if statement in this language. This is what an if statement does.
Right.
There, of
It's
course,
a very different.
What I also like is the few short videos Casey did right before he started Handmade here about C.
Casey's were good, but they still went in with the idea that some sort of programming.
Well, there was a couple things about them that were like they were a bit meandering in the sense that there wasn't like it's not as if Casey sat down and was like, okay, this is going to be the best tutorial that I can make. Yeah. It was more like, all right, I'm gonna just talk and teach stuff.
It was also,
and I'm gonna do whatever the next thing pops in my head is.
Yeah, it was also him just testing, like, does this streaming work?
I thought his goal was C on Windows too, because he was showing some because Windows has weird things with C and stuff like that. I think that was his main goal.
Yeah.
Because C's not the same if you're doing environment or Windows environment. We have D words and all that other bullshit we don't care about, but it still exists. So.
Yeah.
I mean, I did find that helpful. Because it did kind of it did remind me of the stuff that I'd previously learned years and years ago, just simple shit like two's complements, binary.
Yeah. It's all right, but if you could either take Casey or take what Casey's thought on that and make it more concise and a bit more focused, I think you'll have a very decent tutorial.
See, and it confuses me because there are good C++ tutorials that exist, but in C is a much simpler language than C++, a significantly similar. If I get I have a book, I have books behind me. My C++ book is this thick, my C book is that small.
Mm-hmm.
It's an actual thing.
It's very, very small.
Yeah, that's what I was just gonna. Yeah, that's what I have. Yeah, it's confusing why nobody's covered it because C is a pretty basic language. It's not changing, so there's nothing. They don't need to be updated anymore. It's
yes, not like.
I mean, they do update it, but they don't update. They don't update it when they update C++, right?
No.
The changes to C are oh, we're now going to do strict aliasing on your pointers and screw you. Whereas the changes to C++ are we've now introduced a new kind of template called a template with X value references, right?
And move semantics and that sort of weird.
That's C++. So yeah, there's kind of a difference in how the changes are being made there, but there's not as much evolution in C, I don't think. But yeah, it is. I don't really know of any great tutorials. I mean, you say there are good C++ ones, and I'm not disagreeing with you, but I even in C++ never felt like when I was learning there was that that much out there that was any good besides just learning how things work by asking questions.
I think I say good because C++ is a ginormous language, and you're not going to really be where I would consider the good level at C++ unless you read the spec, because there's just so much in C++.
Yeah.
There's 11 functions generated for each class you have now or whatever bullshit. It's little stuff here and there that you just never actually
if you made
actually matter.
If you made an entire video tutorial on basically the entire C++ spec, you would have 500 episodes.
Yeah, C++ is just I think C++ is too big to cover for me to say what's good and what's bad, because there's so much going on in that fucking language.
So I don't personally remember learning how to program, but it wasn't in C. I know that. Did anyone here learn how to program in C?
No.
Well, I mean, I kind of am learning to program in C, although I mean, I learned actually kind of conditional stuff. I learned that through shell scripting. I think I also learned initializing variables in that as well.
Yeah,
which is
some of
slightly different.
the core stuff, like the very, very foundational stuff, is kind of the number one, like the hardest hurdle, I think, and it takes to go from not being able to program to being able to program is, like it's a sequence of instructions and there are values that are being manipulated. Like it's somehow so simple once you're there, but it's a little bit.
Yeah, but I mean, I didn't really get much further than just knowing the conditionals and variable. I didn't really get much further than that. So I suppose I am kind of learning a lot of fundamental programming stuff through doing it in C. Like
But there,
filling an array, iterating through it.
one way I learned a lot of C is just by watching Handmade Hero and just picking up of how Casey did things, and I could just sort of, oh, that's how you do this. That's how this and that and that. So that's how I've learned most things C wise is watching Handmade Hero and Sean McGrath and Sean Barrett, and just watching what they're doing. Can we get like 4 more Sean so you can just keep saying Sean forever?
When I started programming, I started in Java, so I started in a ginormous language like that had a million things, and I used their, I wanted to make games, and I still want to make games, and I started with their little Java drawing thing where you could you could use their software render, and it was really bad, but you could still get like 2D like RPGs going or something with it, and that's how I started. So I started with like a ginormous language, which I don't know, I probably wouldn't. I don't know what language I would even tell people to start with, because Java is a horrible language, just because of just the size of it. Like there's the issue with, I think, learning a language is getting the stuff that you actually care about, because there's so much in it. A lot of the tutorials just teach you shit you don't care about. Like there's so much.
Well, we had an interesting conversation. I don't remember if this was on stream or not, or if this was recorded or not. But before Zach showed up, we were having a conversation about how Miblo is learning to program. I think this was not on the recording, so it might be interesting to talk about now.
The compression. How he
does? The stuff about how his approach to learning C is
on unofficial recording.
Unofficial recording, great. Yeah, we talked about how he's learning all of his practicing C programming stuff is also him learning to program, and he's been implementing figuring out on his own how to do a sort. And then implementing.
No, this is on official recording.
That was on an official recording?
That was on official recording, yes.
Well, I'm just updating Zach then.
Yes.
And doing a Burroughs-Wheeler transform, which is a fairly high-level algorithm.
Yeah.
That's a very unusual, not necessarily unusual bad, but it's not. If you were to ask a teacher, how do you teach someone to program C? They wouldn't say, well, first you have them sort, and then you have them do a Burroughs-Wheeler transform. But that's what he's done, and I'm curious if that's the right way to do it.
I suppose what I'd say about this is it's taking the line of thought that programming is about solving problems. Now, I'm fairly sure that on one of the old streams, maybe an old Abner interview or something, it was described programming is about solving problems. So really, I'm kind of using the focus of problem solving. Whether it's like sorting or the run length encoding, I'm using that to kind of give me the springboard to learning these, the underlying stuff that has to go on. Which is like the iterating over an array, filling a matrix with a shuffled version of the array.
Yeah,
so it's actually it's a self-contained thing that would be usable. But I'm not actually making it for the thing itself. I'm making it so that I can learn the techniques of making it. If that makes sense.
Yeah, it does. And that's what all programming tutorials get at the beginning is we're going to learn, first it's here's how you put something on the screen. It's hello world, and then second thing is usually here's how you iterate.
It's statements, isn't it?
Yeah, it's here's how you iterate. I've always seen that the next thing you do is variables, right? Next you learn how to print a variable and add things together in variables, and then you learn to do a conditional on an input maybe and stuff like this, right? And then you build up from there. And that, in a sense, it seems like the right thing to do because you're breaking it down to the fundamental operations. But I think that when people sit down to teach something, they often do it the wrong way because they're doing it from a perspective of I've now learned it and I'm going to break it down to the fundamentals. But the real fundamentals are more about here's how you problem solve on a computer, and it's a little more abstract than here's what a variable is and here's how output works. And yeah, I don't know if that is necessarily the right way.
That's what I always found the best tutorials. They don't actually do this like here's how to do if they say we want to make this thing and go through it. And they usually take a much simpler case than a Handmade Hero, but they come up with a single project they can make to teach the language. That's because that gives purpose to everything you're doing. You're not you're just doing variables just because you're doing variables because you need this to store the hit points of this object. Like that's what I usually found is when you can see. That's my usual problem with math. Is like when I see this thing, I'm sitting here like I don't need. Why should I use this? Why I can't put a context to the concept. But if you go with okay, we need to do this thing. It's very easy to say. Put context on the concept because we need this if statement to make sure we don't die each frame.
And I don't know if you guys had this issue when you were learning programming too, but my issue was piecing everything together. Because once I had I remember there were things like that I just didn't know how to do, so I would ask someone and they'd tell me, and I'd be like, oh my gosh, this takes. I'm like, I know how I knew that. It's like it's piecing everything together. It was a huge issue for me. It's like I'm like, oh, I have to do this thing. I know these other things that do this actual thing, and just piecing it together to make it work.
Yeah, when I at school, was what I'm trying to get to. At school, when I'm with other people learning to program, the interesting thing is at least at my school, there's kind of a wide range of levels of experience where I'm on the pretty far end of the range where I came in and was pretty much ready to pass all of the all of the sort of entry level classes without attending and like blast through and not do anything, because I'd been programming for a long time before that as just something that I knew I loved to do. And some of these people decided that they wanted to learn to program when they came to school, which meant they actually had to try pretty hard in those early years just to get those basics down. And the thing I noticed is I hadn't had a chance to observe this in myself, because I was by myself and isolated when I learned how to program. There's no programmers around me, and I had no really chance to reflect on any of this. But at school, what I noticed is a lot of those people who were just learning, when they got to their third and fourth year, the problem they were having with what you're describing is I can imagine how to write that algorithm and how to write that, but how does it fit together to do the big thing? Like, how do I link up the indexes in this array here with the strings that I stored over here? And I'm like, dude, it's just you index into the base of the array of the characters, and that gives you the string, because that's why he goes, oh yeah, that makes sense. And it's like, yeah, it makes sense, but it's just this weird thing where it's sort of I think it's just a confidence thing in the sense of I can't just randomly put certain things together, but really what you start to do when you get good is sort of keeping track of, all right, so I've got this array of indexes and this array of indexes, and the solution to this is going to be to index into that, get an index, and then use that to index into this, or the other way around. And I just got to think which one is the order that makes sense based on the meaning of the data, and then it works itself out, right? But getting the confidence to make that leap is something you only get by experimenting and asking, how do I finish this?
Well, I think it doesn't help because when you're learning all these things in school, you're learning them as these are variables, these are strings, these are this. You're not learning it to make something. So when you're actually doing it to make something, it's very hard to put all those concepts together.
And that's why I say advocate for it. We want to make this thing because it instantly says here's how you put them together.
And then you have something at the end, which just helps people more, because people like when you have a little thing at the end you can play with or whatever. Yeah, it just shows that you actually did something instead of just I'm learning programming, but I have nothing to show because I've been sitting down for 50 hours with the lectures on how to make a function or whatever.
Yeah.
I mean, I haven't hit this problem yet of not being able to piece stuff together, because I've been going through it quite systematically.
And you've seen how Casey's done it too, because Casey's he shows how code goes together the way I think he does it is he just writes and then he pulls it out and puts it in different functions and shows how it works.
Yeah, he does.
That's also together, which helps a lot.
Yeah, I think also the thing is write the user's code first. That really helps with it, because you're not thinking how to piece this together. You're saying I want this to work together like this. And then you just write the code that does that.
Yeah, whether it's okay, I figured out how to implement this, now I got to code compress this, and then I'll figure out, then it'll already be pieced together, and it'll just be cleaner. Yeah. Or if it's the other direction where you're okay, I don't know how to implement this yet, but I
Want to use it like
yeah,
this.
I want to use something with these features, and so this is how it's going to have to fit together from this end. I think either way that's like the big structural problems in programming are kind of one of those things that you got to see someone do it right to.
Yeah, like this is an issue I just literally had yesterday or like a few weeks ago probably. Yeah, no, because I just got back to work. So I was writing this like crazy like this. I don't even remember what it was. It was something I had to for work, and I like basically in my head I could visualize how this thing works. But it's like once I had to separate it all out into a class and add all these like operator overloads and do all this crazy stuff, my mind was just scrambled everywhere. And I mean, and like I got to it. It's just I had to write it. I just had to sit down and write it all. I was thinking about it too much, and that happens to me all the time with OOP code because you're supposed to the whole point is you're supposed to prepare it before. Like you're supposed to be like, oh, we're gonna have all these functions that you just go through and you fill out all the functions. And that doesn't work for me at all, like ever.
Yeah, I'm not sure that works. I think that the only time that works, and I've thought about this, so this is quite off topic at this point of tutorials, but it's interesting. I've seen a very good reason why people would write code that way, and it's because it makes it very easy for lazy teachers to teach a programming class. And what I mean by that is all they have to do to give an assignment is give a header with the functions that need to be implemented, right? And descriptions of those functions. And that's the way I think OOP really comes about is you're like, look, I want to give someone an assignment of get these things done. I already know the interface. Like imagine you're a good programmer who's like doesn't realize you're causing any damage by introducing OOP, but you're just like, look, I've written the usage codes first. I know what it needs to look like. I just need a way to communicate to my, my other programmers who are going to take up the task of implementing it, what I want implemented. And kind of from there, it's like, well, what I'm doing is planning out my class and then giving it to them, and then they're implementing it. But then when you go, okay, so the first thing you do, like if the lesson you take from that is the first thing you do is you plan out your class, then you implement it, that's actually not right. Like OOP was sort of just, I think, accidentally looked like the right thing to do at the time when you realized that you want to write a usage code and then fill it in. But then you took the usage code part out and just goes, okay, just plan the interface and then hope that the usage end and the implementation end both match that. Like that is then completely disconnected from reality, and that's where OOP is now. That's my personal theory on where that sort of comes from.
Yeah, I don't know. It was something I realized because like I remember I had to make a singleton too. I'm like I've never made a singleton, and like it's been like 5 years since I've used singletons. I think I used them when I was using C#, and I was like, oh, that's how it works. What the fuck?
Singletons are one of those things that are doubly awesome because like as soon as I learned what a singleton was, basically for anyone who hasn't gone down the OOP rat hole, what a singleton is first principle number one, globals are bad, right? Because a global is global state, and it means that if you have global state, then anything that touches that global state is completely dependent on the value of that global state when you call it. Like the same function can have many different results with the same inputs if it is relying on a global. So globals are bad in the sense that they kind of make code harder to write. They're also bad for threads and so on and so on.
Yeah.
So globals are bad. Okay. Now keep in mind the whole point of OOP is to hide bad things from users, right? Make things look good. Yeah, and since global is a bad thing, a singleton is a way of hiding a global and calling it a singleton instead.
Yeah.
All a singleton is you hide somewhere in your code base a pointer that you initialize to null and it's global, and then you have a singleton call, and when you call that singleton, it allocates some space with new if you're in C++, so it's like some heap or something, and points the global pointer at that thing and returns it. Now, no user code is ever allowed to get that global pointer. It only ever calls the singleton and gets the global pointer returned to it. Now, in one instant, everyone, and including me, when I believed in OOP, I was like, well, that doesn't really fix anything, does it? That's still a global. That's literally the exact same thing. It does nothing, but I still wrote them down. I still wrote singleton.
It's a getter for a global, yeah. Say the Unreal Engine uses them everywhere. Like the base Unreal Engine, I think it's called G Engine, is a singleton that you have to grab out, and I was like, holy crap, I haven't used these in forever. What the hell? Yeah.
Well, it's singletons are just super awesome to me because it's one of the places where the sort of silliness of OOP is very blatant in the fact that it's like the problem is global, so what we're gonna do is pretend like this isn't global.
Yeah, we're gonna
Like-
literally.
They also hide behind saying singletons hide ensures there's only a single instance of this existing,
yeah.
and I'm just saying like, but that global does that too because you have only a
Right.
single
A
point of
global
entry.
ensures is only one of them, right?
Yeah.
It's just as good, yeah.
And they say like you ensure that if the singleton doesn't exist at calling, it will create itself. Okay, so put an if statement and around the call, and then if it's not there, make it and call it. Like,
I mean, yeah, the singleton. The only time you could ever actually want a singleton is if there's a gigantic object that you don't always want to allocate, but you sometimes want to allocate.
Yeah.
Okay. And what application conditionally needs a gigantic object? Like on this particular run of the application, we never needed the main data structure that contains all of our data, but on this one we did. Like I can't imagine ever not initializing it eventually. So
yeah,
just store it as a global. I don't know.
Yeah, I don't know. I was like, it's just there's so many things that you just like realize like, why was I doing this?
Mhm.
It just comes to you sometimes. You're like, oh my gosh, I used to do all of this bullshit.
Yeah, and it's kind of interesting because
Have you thought about it yet? Like, have you ever like I don't know. I sat down and thought about this like last night after like I was done with work and all that other stuff. I'm like, I used to write so much extra code. There's so much extra code everywhere.
yeah.
Like each class probably had 4 or 5 extra functions. There was just so much extra stuff that didn't need to exist, and it's like it finally just kind of like, oh wow, you don't need to. I'm not doing any of this anymore, and it's really awesome.
Yeah, I definitely had when I was doing that back in those days. I had it like in the back of my head a little intuition, like something about this is weird. Like with the singleton in particular, I was like, this doesn't really make sense, but
it just seems
I did it
overly
anyway.
complicated.
Yeah, I did it anyway because I was like, well, they say to do it, and I'm just not. I just don't get it. I don't get the secret sauce, so I'm gonna do it. And kind of like what Handmade has really meant for me is learning to pay attention to the intuition in the back of your head more than anything else, because the intuition in the back of your head was always right, and you were ignoring it, and now you're gonna pay attention to it instead. Like that's kind of a big part of it. I think is like learning to be in tune with your gut a little bit.
Yeah,
I think intuition is a big part of Handmade Hero because, like, the way Casey also describes the stuff, he describes it in intuitive ways. So yeah, I think I think it must be a very important part of Casey's like philosophy, really, like relying on your intuition and trusting it. Well, I mean,
and even being able to hear it when it's giving you a message. I think knowing that it's there and what it is, kind of.
And I'm sure Alan's on the same page as me. Like when you asked why do we use OOP, you really never got a reason, did you?
Well, I didn't. Yeah, I guess
the reason I got was because everyone used it. That's the reason I got. And it's like,
I never really asked because I never wrote OOP that was in a team where I wasn't the leader. Like I was on teams where it was like me and a friend, and the friend was like doing OOP because I was forcing them to. And my reason for why we're doing OOP never had to be explained because they wanted it anyway. Like I never really had a team structure where OOP was forced on me, I guess.
Yeah, it's it also, as you said, it comes down to trusting you. So like a lot of this OOP kind of also, at least I think so, is it empowers this imposter syndrome you have yourself, where you have to pack things away and keep things from yourself because you cannot trust yourself.
I mean,
right.
You think, it does make you feel good, though. You write a lot more code. You feel like you're getting a lot more done. It does. Like, honestly, I'm not even joking. It literally does.
Well, then you measure by the wrong metric, because I don't think, I did a lot because I learned a lot of code. I think I did a lot because I got a lot on the screen.
No, I'm talking about like new programmers, though. I'm sure they think that. Like when you start out, you judge how much you get done by your amount of lines of code. It's just how it is.
Yeah, if you're a new programmer, there's definitely once you're an old programmer, and by old programmer I include myself, not as an old person, but somebody who's like you've done a few things and you're no longer interested in like exploring so much code as much as like exploring the result. You're really just after a result.
You're not trying to reduce the amount of code you write. Instead of increasing it.
Right. Well, as a new programmer, though, there's definitely, absolutely, I can agree, there's just something satisfying about OOP. Like, there's something about when you finish writing a class, you're like, well, now I am satisfied with that code I wrote. Which you don't, it's because it feels punctuated. Now, it turns out to be a lie, this was kind of what I learned at Push, was like, all the things I felt satisfied about turned out to be crap that I had to rewrite anyway. Like I had to improve my classes; they weren't done. I had to add new functions, and I had to refactor their interfaces and things that and I was like, I don't think there is such a thing as like actually planning the code and then writing it. I think that is kind of the lie of OOP is you sit down with a perfect plan, and if things go wrong, it's because your plan wasn't good enough. But it's like your plan can't be good enough. It doesn't make any sense. Like you can't know what you need to do until you're at the point where you need to do it, kind of.
So 90% of the reason I used to have to whiteboard program is to plan out the whole interface I had to do, like this crazy interface, and like now it pretty much doesn't even exist. So
how do you program where you work? Since I know you have to do you like write out? Do you like get a class assignment and then fill it out, or do you get solve this problem and then you oopify it afterwards, or what do you do?
Yeah, no, I solve it and then I oop it.
I see.
And then I throw it into the function or whatever. It's so much easier. It's just like because I'm like when I start writing the code, I don't know what I need, so I just write it and then I just throw it in there, and I usually write it in my own style first because I just don't register that I'm writing in somebody else's code base, and then I have to refactor it and throw it into some functions. And I have Visual Assist, so I can just say generate function, generate function, generate function, and it does all that for me, and it's awesome. So Visual Assist helps a shitload with that.
Well, that's another good thing about OOP is since it's so formulaic and sort of boilerplate that you can get your code assist can be better, right?
Yeah.
Since you have to write so much more code, but it's like getters and setters, well, we can just generate those automatically.
There's so much I generate. Yeah, I generate probably most of my classes. I probably generate like 20 to 30% of the code. It's Visual Assist. I don't know if you've used Visual Assist in the last like year, Alan. It's really good now. Like it's gotten like really, really good.
Interesting.
Yeah, I mean it's stuff I never needed in my own code base, but it's like if you're using this, it's really cool because you're just you're saving yourself a lot of like lines of code, right? Because I used to hate having copy out the function, write it in the CPP file and all that stuff, and it just generates. You just I literally just Control A, select the whole class, right?
Oh, it makes the whole header for you.
Yeah, no, I can do all that. Yeah.
That's awesome. That's good.
Yeah, Visual Assist is some really cool shit recently, and it's really fast too. Like compared like if you've ever tried to rename something in Visual Studio, it's a big problem for it. It takes it a long, 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 long time. Visual Assist is like instant. So I literally use it as just a faster extension on Visual Studio because Visual Studio can do pretty much everything I need for work at least, but it's just so slow at everything. So I just use Visual Assist.
Yeah. Okay. Makes sense.
Yeah. I don't know.
Just while you're talking about that, I was thinking like I have occasionally done not the usage code first, doing the function first.
It works for some things.
Yeah, I mean the only times I've done it really is when I was doing the swap. When I was doing the sort function, I did a swap function instead of doing the swap in line inside the sort. I actually left it down as a function first of all.
If you know what you need, it's like when I wrote my linked list library like forever ago. I knew what I needed, so I just wrote out all the functions and then went down and just filled it all out. Like if you know what you need, it makes it a lot easier. But like most of the time, I don't find myself knowing what I need. So that's the issue.
Yeah. So you know what you need, and you know how to implement that stuff. I think in that case, then it can work.
I think and this is something that I hope I start being able to do better. Like once in a while, I notice myself being able to do it, but I don't really have the skill yet. But is sort of having like preemptive plans for things you expect that you're going to need or that are going to go wrong or something like this. Like I have not yet got a very good sense yet, and I think that's something that only comes with experience of like, all right, if I was doing this the very clean handmade way, first I would either write usage code and then implement, or I would just write everything out in line and then compress one or the other, right? Because otherwise I'm going to guess and put a function in there. But once in a while you're like, well, I kind of think I know that I'm going to need this. Like, I'm pretty sure. And like, once in a while I'll make the leap and go, all right, I'm going to write the function first without usage code or without writing it in, without compressing it. Just write it first. And I would say about half the time that still bites me and I have to refactor it. And I feel like over time I'd like to get to the point where I only ever do that wrong, only ever like preemptively add something that I don't have proof that I need and get that wrong on rare occasions. Because being able to preemptively write things out does make you faster than doing it either of the other two ways. I think that's why a lot of code gets written that way. Is it feels faster to just go like, all right, I'm gonna need that, boom, and then if it works out, you did a good job. But sometimes you waste time.
Yeah.
Yeah, I for sure. Yeah, like that's most of the time.
It's usually like usually I do preemptive if it's something I have done before. So but then again, then I know I need these things. And I need these things, and then I write them, and then I start using them because I've done it before.
Here's a totally random thing I just thought of. I've started to do this with my files too, which I didn't really see coming, but I've started to, as I go, the inclusion of new files in my project is actually just code compression, in the sense that I'm going, okay, this thing here appears to be ready to move into a separate file, and then I cut and paste it into a different file and put an include where that used to be, and then I let things kind of grow that way. So if something's or if I realize that I'm going to need this thing in two different places now. So like if I have a file format that I've been like writing a parser for, and then I get to the point where I need to, I'm done writing the parser, and now I need to write a generator for that file format. I then pull the structs out and put that in a header, and that's kind of where my files come from now, is they just grew out of a file that already existed. I don't really open a new file and type code into it anymore.
Yeah, I get
Yeah,
it.
no, I know.
Oh, I see what you mean. Right? Yeah.
I think I do it a lot too, where you add files as they're needed instead of preemptively saying, oh, I need, like, I'm going to make a file format, so now I'm making file format file, and then write the code in there. I'm just like, okay, I'm writing in here, and then like, okay, I need it, so out.
Yeah, most of the time when I write a file format, I know I'm going to need that as a header eventually. But I still haven't gotten in the habit of writing that as a header, because it just makes more sense to write that in the code that I'm writing right now and then pull it out later.
Yeah.
So yeah, the only time I ever make a new file and type code into it is at the start of a project now. From everything else I've done in the last couple months has been copying stuff out of an existing file to make a new one.
Yeah, it makes sense.
Interesting.
Yeah, no, that 100% makes sense. I don't
That's
know.
the first layer of compression than Casey does as well, because he does do the new file, doesn't he? And then he starts doing the new system in that file.
Yeah, but I think it's come down to this, like, as Alan talked about, like, experience. Like, Casey knows this needs to be
exactly. That's what I'm saying. Is someday I think maybe I'll go like, all right, I just know it's easier to start with a new file here, but I've kind of boiled out all of the guessing work out of my programming at this point, where I'm not making those preemptive moves very often because of the fact that half the time they burn me. I'm trying to never do anything preemptively, and I think I could be faster if I had enough experience to do the preemptive stuff again. But at least it has prevented me from writing crap very often.
And with that, that's I think it's a fine note to end on, because we've been going about 45 minutes here, so it should be fine. So I hope everybody enjoyed. It's a little talk about what we think about tutorials. Hopefully the Handmade Network guys can use this when they're going to go out and figure out all the different tutorials they want. Because if Abner's doing all of them, then it will take about 10 years before the first episode comes out.
Exactly.
And the first one will be about how to drink chocolate wine correctly. Which again. See you, everyone.
Bye-bye.
Well, for now.